In this section, we dive into the world of task types. BPMN provides a variety of activity types that allow you to precisely define the different activities and actions that take place in a business process. From simple, unspecified tasks, which we have often used in our examples so far, to more specific tasks such as sending messages or executing business rules. We will cover everything in detail. And lots of other types and subtypes too. Tasks in business process modeling are fundamental elements that represent a single unit of work within a process. They are building blocks for modeling business processes and play a central role in defining the specific actions to be performed in a business process. Why there are different task types? The answer lies in the diversity of business processes themselves. Each process consists of a series of steps or activities that have different requirements, goals, or outcomes. The different task types in BPMN provide a rich set of modeling options to accurately capture this diversity. They allow modelers to represent not only the activity themselves, but also the type of execution, the systems or services involved, and the required decisions or conditions that are relevant to the progress of the process. Through this section, you will gain a deep understanding of the application and meaning of each task type in BPMN. I want you to be able to model your business processes clearly and concisely to improve communication and execution of business strategies. So, let's get started. Welcome back. In this chapter, we will cover the receive activity type. We have already used it briefly in a previous chapter, but let's go into a little more detail here. The receive task is a task type that is modeled to represent the receipt of a message or other specific events without requiring any additional processing or manual work. In fact, it's not really a task in the truest sense of the word activity. Therefore, the main purpose of the receive task is to define a waiting point in the process model where the process waits for a message from an external participant. This external participant can be another process, a system, or a person. For this reason, a message catching event can just as well be used instead of the receive task, as it fulfills the role just as well as the receive task. In my opinion, the event makes it even clearer that it's essentially only about waiting for a message and not about an activity. In BPMN diagrams, the receive task is represented by a rectangle with rounded corners that contains a letter symbol on the left-hand side. This symbol clearly identifies a task as one that is waiting to receive a message. Let's take a classic example of a theoretical application scenario for the receive task. Imagine an online registration process waiting for confirmation from a user. At the point where the confirmation is expected, the process should use a receive task to indicate that the process will not continue until the confirmation is received. Why I just talk about a theoretical deployment scenario? Well, our process design has a small but crucial pitfall, and it lies precisely in the breakpoint function of the receive task. What happens if the user does not send us the confirmation, which is a very common case in reality? Exactly, nothing. Or to be more precise, the token remains stuck in the receive task until it has gone rotten. Although not very nice and therefore not really good process design. How can we solve the problem with what we have learned so far? Think about it for a moment, but I'll give you a little tip along the way. Think about the events and perhaps a special gateway. Okay, let's go to the solution. If you now have thought of the catching message intermediate event, this is a good approach, but unfortunately not the solution to our problem, because it also waits for the message that may never arrive. If you don't want to do without the receiving task element, you can solve the problem of the timeout for the activity with a boundary timer event. What happens here? The token runs until the receive task, which should wait for the confirmation from the customer. So far, everything is as in our first example. However, the boundary event of the timer type allows the token to leave this activity even without an incoming message. So if the message does not arrive, but the timer event occurs, the token is routed to the alternative path and the process ends with the termination of the registration process. But important here, as the process is to be finally redirected to a path, the timer event must have the property interrupting, as we do not want to keep the token in the receive task. Another very elegant option would be the event-driven gateway. I have modeled this here. In this case, the token runs into the gateway and remains there until one of the modeled events occurs. If the user's message arrives first, great. Then the token takes this path and we have a successfully completed registration process. But that was not our problem. However, if the configured timer event occurs first, the process takes the path to cancel the registration process. So there is not always just one right solution. So the receive tasks are useful in processes that require clear communication or interaction between different participants or systems. They define a breakpoint in our process. This helps to identify the points in the process where external inputs are needed to continue. However, especially when you're dealing with communications where there is no guarantee that the communication will actually take place, you should always think about a fallback solution in a form of a timeout as described above. So much for the receive task. See you in the next chapter. Welcome back. Let's move on to the next type of activity, which you've already seen briefly, but we want to go a little deeper now. The send task. A send task is the counterpart of the receive task, with the crucial difference that it stands for sending a message from a process to an external participant. So the send task is used to clearly define when and how a message is sent to an external participant as part of the process flow. When working with the concept of send task in BPMN, it is important not to take the term message too seriously. This is not about direct communication between people. Send tasks play a central role in the automation of processes by enabling the exchange of information. This includes the sending of messages from one system to another, for example from one software application to another, or the transfer of data between different processes within a company. The aim is to ensure efficient and smooth communication that enables business processes to be handled automatically and effectively. But of course, the recipient can also be a human being. In a BPMN process, a send task is usually executed automatically, which means that the process sends a message without human intervention. This can be done by various mechanisms, such as email, web service calls, or messaging systems. This task is used asynchronously. What does this mean? In terms of communication between different systems, services or participants, asynchrony means efficient data transmission, as messages or information can be sent without the sending process having to wait for an immediate response. In our example, this means the send task sends its message and has done its duty and obligation. It does not have to wait for a response or even a positive confirmation that the other party has received the message. So, send tasks are particularly useful in processes that require clear communication with external parties. They can be used for notifications, order confirmations, information requests, or other types of outgoing communications. Two things to keep in mind. First, the recipient group of the send task is always defined by you and should be marked with a message flow. And secondly, the content of the message that is sent must be defined in advance. This can include fixed data, variables, or a combination of both that are important to the recipient. Let's take another example. Let's say a company has a process for handling customer orders. After the order has been processed, a send task could be used to send the customer an order confirmation by email. The send task therefore marks the point in the process at which communication takes place. By explicitly modeling send tasks in BPMN diagrams, You as a process designer can make it clear where and how information is communicated from the process. This not only helps to understand the communication flow within the process, but also to clearly define and manage interfaces to external participants. You will come across send tasks again and again in your diagrams. So much for this task type. See you in the next chapter. Welcome back. Before we look at another type of activity, however, I need to explain another concept to you, namely parallel and sequential multi-instancing and the loop. Wait, before you close the course in shock. That sounds far more dangerous than it really is. Let me explain it to you using a really easy to understand example. Let's assume you have to design an order process in an online bookstore. That means the order is received, it is checked whether the book is in stock, the book is then taken from the warehouse or the shelf, packed and dispatched. So far so good. But what if the order contains, say, 3 books? Should the process then be started 3 times? That wouldn't really be ideal in terms of shipping cost, as each book would then be shipped individually. Of course, you could now use a parallel gateway and split the process in 3 paths and merge them again before packing. But this is also not ideal, as the process design only works for exactly 3 books. We need a different solution. And that's where the concept of instancing and loops come into play. Let me show you how I would model this. So the order comes in and I check availability via bulk request in the system. Can you see these 3 vertical lines here? They mark this activity as multi-instance parallel. This means that the task is queried in parallel in the system based on the number of books requested. However, the query runs for each book. In our example, a separate instance is created for each book and the task is executed in parallel. This means the individual instances do not have to wait for the previous query to be processed. The nice thing about this is that I only need a single activity. In the next step, the books are retrieved from the warehouse. Here too, each book creates an instance. However, this cannot run in parallel as each book is probably in a different place in the warehouse. Therefore, the individual instances are executed one after the other. So, sequentially, for each book. But again, only with a single activity with several instances. Now we come to the activity pack books in a box, and therefore to the loop. The loop means that this task is repeated until a predefined number of repetition is reached, or a certain condition is met. In our case, the books are packed in the smallest box available to save on shipping costs. But now we can no longer close the lid. So we repeat the process with the next largest box. And we repeat this until the box closes and the condition is met. But where is the condition or the number of repetitions? Unfortunately, this cannot be said in general terms. It basically depends on the use case, so the purpose of which a process is used. If the process is to be executed automatically later, BPMN modeling tools usually offer a way to capture these conditions directly in the model, even if they do not appear in the visual graphical diagram. This information is crucial for the execution of the process in a workflow engine. However, if your process is generally to be modeled for visualization purposes for the human observer or for pure documentation purposes, so-called annotations are a good option. However, we will look at this later in one of the following sections on the artifacts. The exact syntax of the condition can vary depending on the modeling tool used and the execution environment. Often a formal language or a scripting language is used to express the condition. So that was the loop-in and the parallel and sequential multi-instancing. That wasn't so bad, was it? These concepts will definitely help you to model really good processes. But now let's continue with the activities. And see you in the next chapter.